Good morning. Now I am going to discuss about torque transducers. So torque transducers are the transducers which are used for the torque measurements. So these will convert the input mechanical torque into an electrical output signal. So that means it senses the torque and it will show the output in forms of voltage which can be calculated for the torque measurement. So here for this torque transducers, it will be having a shaft-like structure. This shaft will be having on the shaft there are strain gauges attached. These strain gauges are attached likewise. Two strain gauges 1 and 3 will be placed in the axial direction, and the other two strain gauges are placed in the circumferential direction, so that the angle made by the each strain gauge should be 45 degrees. Each strain gauge should be 45 degrees. So that means whenever there is a torque applied on the shaft, that means in this direction it will be applied in clockwise direction. Next in this other end it is applied in the anti-clockwise direction. There is a twisting force acting on the shaft. So because of that twisting force, what happens is the strain gauge's resistance will be changed. So when the resistance is changed, that means there is a torque applied, and because of that resistance change, these strain gauges are connected to a Wheatstone bridge, so that there is a deflection in the galvanometer, and the deflection of the galvanometer will indicate how much amount of torque in terms of the voltages. In terms of voltage, it is going to indicate. So by this way, you can measure the torque. Next one is the measurement of flow. So this measurement of flow means here the flow means you can measure the fluid flow. Here the fluid indicates either gas or liquid. So this flow can be measured by using hot wire anemometer. So this hot wire anemometer works when electrically heated wire is placed in a flowing gas stream, and heat is transferred from the wire to the gas, and hence the temperature of the wire reduces, and due to this the resistance of the wire also changes. So this change in resistance of the wire becomes the measure of flow rate. Usually, this hot wire anemometer can be done in two ways. That is the first method, that is constant current method, and the second one is the constant temperature method. Coming to the construction diagram of this hot wire anemometer, this is the hot wire anemometer. In this hot wire anemometer, you will be having the ceramic tubing. So this is the ceramic tubing. In between these ceramic tubing, you will be placing ceramic cement. Under this ceramic tubing, you will be placing the conducting wires. These two are the conducting wires, and at the end of the conducting wires, you will be placing the leads. You will be connecting wires so that these wires can be used. You will be connected to the Wheatstone bridge. So this is the construction diagram of the hot wire anemometer. So we shall see how it is going to work with the constant current method. So this is the constant current method. So this is the hot wire anemometer. This is the hot wire anemometer. This hot wire anemometer is placed in the gas flow. So either gas or liquid, whatever might be, for which you need to measure the liquid or fluid flow. In that flow, this hot wire anemometer is placed now. So whenever for which gas you need to measure the flow, that is allowed to flow in this pipe. So when the gas flows in this pipe, what happens is this hot wire anemometer is already heated. That means it has some certain amount of temperature. So when the gas flows here, then what happens is the temperature of this coil hot wire anemometer is transferred to the gas. So the temperature is transferred to the gas. So that what happens, this the temperature of hot wire anemometer gets reduced. This gets reduced. So as it gets reduced, that means the resistance changes here. The ends of this hot wire anemometer, as it is connected to the Wheatstone bridge, it is connected to the Wheatstone bridge, one of the arms, then what happens is there is unbalancing of the bridge. So because of this unbalancing of the bridge, the galvanometer deflects. So here it is, the current is maintained constant. The current is maintained constant, and here the temperature gets changed. So this is called constant current method. So likewise, in constant temperature method, you will be maintaining the temperature as constant. To maintain the temperature constant, you need to supply more and more amount of current to the hot wire anemometer. So the flow which is to be measured is flowing in this pipe. Then what happens is the temperature tries to change. But to make the temperature constant, what we will do is, by using this rheostat, you will increase the current. You will increase or decrease the current to maintain the constant temperature. So by that, because of that, when it is changed, when if there is any deflection, that indicates there is some amount of gas flow that is to be measured by using the galvanometer here. So this is the hot wire anemometer for the measurement of constant temperature method and constant current method. Next one is the measurement of liquid level. So for the measurement of liquid level, you are using this capacitance method. So, this is the tank which is having the liquid. So to measure the liquid, how much amount of liquid is there in the tank, you are placing a metal electrode here. This is the metal electrode. So this metal electrode acts as the one plate of the capacitor, and the tank will act as the another plate of the capacitor. So capacitor means capacitor consists of two plates separated by a dielectric medium. So this electrode acts as one plate and the tank acts as other electrode, so that there is a distance between these two plates, which is nothing but the dielectric medium. And in between these two, if it is connected to a measurement control circuit, then it measures the capacitance, how much capacitance is there. So this is the measurement of liquid level by using the capacitance method. If there is any liquid level change, either increase or decrease, there is a change in capacitance, so that you can measure the capacitance. The advantages of this liquid capacitance method is it consists of no moving parts. There are no moving parts, so that the wear and tear of this instrument, this method will not happen. So this is one of the advantage of capacitance method. The disadvantage of this capacitance method is the temperature. If the temperature changes, there is a change in it affects the capacitance. It affects the liquid level measurement. So that is one of the disadvantages of this method.